Alright, here I want to show you how you can draw the surface development of a complete cone. How you can draw the surface development of a complete cone. So the dimensions of the cone are as follows. For the circular base of the cone, the diameter is 50 millimeters. For the circular base of the cone, the diameter is 50 millimeters, and the height of the cone is 60 millimeters. The height of the cone is 60 millimeters. Now, the first thing that you need to do in this case is to draw the base, the circular base of the cone, which will also serve as the plan of the cone. So, and that's what I've done here. So I've drawn the circular base and I've divided it into 12 equal parts, and I've numbered 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, now having done this, the next thing that I need to do is that I've drawn a horizontal line here. Then the next thing that I need to do is to project a vertical line from each of these points. So from point 1, draw a vertical line meeting this horizontal line at this point, and from point 2, so point 2 and point 12, they are at the same point on the circumference of the circle, so draw a vertical line up here. Then point 3 and 11, they are at the same point on the circumference of the circle, so draw a vertical line. So when you meet the horizontal line, stop it there. 4 and 10, they are at the same point. We have already done that, and that is on the vertical center line of the cone. Then 5 and 9, they are at the same point. 6 and 8 are at the same point, and then so we have 7 here. Alright, so after you have done this, take the height of the cone, which is 60 millimeters. So the height of the cone is 60 millimeters. So this is 60. So I have 60 here. So the next thing I'm going to do is that from this point, so you draw a line like this. Okay, and from this point here, so we draw this line. Alright, then so from this point here, draw this line within continuous line, and from this point draw this line with 18 continuous line. Also from here, so draw this line with 18 continuous line. Then from here also draw the line with 18 continuous line. So I believe you can see this now. So I'm going to number this from 1 to the last one, which is 7. So I need to make this thick because this is the base. It's a thick line. Alright, so the base of this has been numbered. The base of the cone has been numbered from 1. Then here we have 1, here is 2, 12, this is 3, 11, this is 4, 10, this is 5, 9, and this is 6, 8, and this is 7. So this is how it should be numbered. So the next thing that we are going to do is to produce the surface development. So I do my own in this way. And I'm going to explain how some people do their own and how I do my own. And that's what I'm going to do first. So the first thing that we are going to do here now, the next thing that we are going to do to produce surface development, so come to this point and draw a horizontal line like this. So draw a horizontal line like this and call this point. So call this point. So this point, call it point O. Now, if we are opening if this happens to be a seam, this line, if it happens to be a seam, that is where we join the edges of a sector together to form a cone. So if that point happens to be the seam and we cut at that point, so by the time we open it, we are going to have a sector. That's what we want to produce. For a complete cone, we are going to produce a sector. So if this is the point, so where we cut it in order to open it, so this is point 1, I'm going to have 1 at this point as the starting point. So I'm going to have 1 at this point. So this is 1 at this point. And then there is something that, okay, all right, so I have 1 at this point. So the next thing that I'm going to do is that I will put my compass at this point, at the apex of the cone, then extend it to this point 1 here. Extend to this point 1. Then I will bring it here. Actually, so if I put it at 1 here and make an arc on this line, so that means this point is supposed to be where I'm supposed to have my 0. So this is where I have 0, because distance from this is point O, so O is the top here. So distance from O to 1 is equal to distance from here to here. So now I'll put my compass at O here, and then so to reach this point, then draw an arc like this. So with this arc that you have drawn, with this arc that you have drawn, the next thing that you are going to do is that put your compass at 1 on this circle, on the circumference of the circle, and extend it to 2. That means we are taking the distance between arc 1 and 2 like this. Then you put at this point, as we have divided the circle into 12 equal parts, you also make 12 arcs on this arc here, on this bigger arc. So that means here we have 1, then put it here. Here is 2. So you continue like that until you make 12. Alright, so the 12 arcs have been made and I've numbered. Already this is 1. So if we open from here at this 1, we are going to have 1 at both ends. So we have 1 here and we have 1 here. So here is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then we end it at 1 because we open from here at 1 and we're going to have 1 on both sides. So that's it. So the next thing that you are going to do is that, so you take your pen or you take your pencil and you draw in continuous line from each of these points like this. So the method that we are using here for the development of the complete complete cone is known as radial line development or radial line method. So radial line method. So you draw these lines are in continuous lines. So all these lines are in continuous lines. Okay. So alright, so this is the survey development of a complete cone. So this arc from 1 to 1 must be made thick, and line O1 here and O1 here should be made thick, and that's what I've done here. Every other line is a thin continuous line. So this is how you can make survey development of a complete cone. So thank you for listening to me. God bless you.